Technical Toolboxes webinar today, Standardizing Calcs Across Utility Projects with Febin Jos. My name is Kesley Price from Technical Toolboxes, and we want to thank you all for joining us today. We have some attendees still trickling in, so as they join, we have a few items we'd like to go over that we typically cover. If you have any questions on what we're covering, there is a chat box or a questions tab in the top right of your screen. Within your webinar interface, please send us any questions you may have throughout the webinar, and we will do our best to cover all the questions at the end. We'll also send a copy of this webinar recording to all of you, including those that are registered and weren't able to attend live. That will come via email within the next couple of days, and you'll also see this available on our YouTube channel shortly after that. All right, let's get to the good stuff, Febin. I will turn it over to you to cover the agenda and move forward.
Thank you, Kesley. Good morning, everyone. My name is Febin Jos. I'm Director of Product at Technical Toolboxes. Happy to join the call today and just walk you through the many benefits that we give our users in Pipeline Toolbox. So we have a very interesting agenda for today. So it's mostly centered around an introduction to Technical Toolboxes and Pipeline Toolbox, our premier solution that's centered around pipeline integrity, pipeline construction, and different aspects of management of the pipes. Then we have few use cases that we would like to show you what the tool can do and how it can help you in day-to-day life. Then we will essentially talk a little bit about some of the workflow standardization process that we can do with Pipeline Toolbox and the tool. And finally, it's live Q&A, and that's simple as that. And that's what we're going to do for our agenda. Starting off, let's have a quick preview on what Pipeline Toolbox is. PLTB or Pipeline Toolbox, it's our first commercial product at Technical Toolboxes. We introduced that in 1997. So it currently has 250 plus pipeline engineering calculations that are consolidated in one single location. We have separated that out to gas and liquid. The modules there have been organized into design, construction, integrity, operations, and maintenance applications. So you will see that as I show the demo in detail, but that's essentially how we have structured it for ease of use. Regarding the regulatory compliance, we have standard calculations that's standard across all different modules. So it is adhering to either the PHMSA, the DOT, the CSA, ASME, and other industrial code standards. So we don't have any proprietary solutions within Pipeline Toolbox that's not in accordance with any of the code standards there. And finally, what does Pipeline Toolbox do? Pipeline Toolbox is a simplified solution that can do stress analysis, pipeline crossing, hydrostatic testing, hydraulic modeling, the different modules, and the goal is to essentially have engineers quickly assess, plan, and verify the pipeline integrated procedures that they're doing. The tool automates data input. It can essentially have that integration with the GIS map and allows you as a team member to essentially do complex engineering assessments with confidence. And that's our goal here with any solutions that we build at Technical Toolboxes. Moving on, what is the solution framework that we did to essentially build Pipeline Toolbox, right? So our tool is cloud-based, so you don't have to have any hard installs or have to essentially update it to be updated when a new release comes in. Since it's in cloud, I mean, you have a cloud architecture, we are capable to essentially put routine maintenance and routine updates to the solution. Pipeline Toolbox is hosted in our Hub platform. Hub is a platform that we have developed for midstream engineers and the utility engineers that can house many different applications, and Pipeline Toolbox is one of the applications that's there. It's a standardized solution, so we follow the industrial standards and the best recommendations on all calculations we do in Pipeline Toolbox. It is compliant with all the latest code standards that you work with in the industry. The next piece is what comes out of the calculations, right? You have automated reports in PDF or Excel that you can generate based on your analysis for your record keeping. That is something that's there. The next thing is we have to think about streamlining your workflow. There are certain kind of workflows that you follow, and we want to make sure we are equipping the solution to essentially handle that. And that is something that is available here. That is something that we can do within the Pipeline Toolbox. Now, the next thing is collaborations. I mean, you as a team member or an engineer, you would like to collaborate with the rest of the team. I mean, you have the capability to essentially handle the collaborations and sharing of your cases and the analysis that could essentially help streamline your workflow. We are SOC 2 compliant, which means all the security aspects can be handled there, and that is something that we can essentially do within the tool. And the streamlining of the workflow is done through what we call as our dashboard. You will get a flavor of all these things as we go deep into the solutions there, but that is essentially how we thought about this as a solution framework that would be applicable across the different utilities and different services that you do within your day-to-day life. Now, the next thing is we are going into a live demo of the solution. So let's do a login process. Let's see what the solution does. And we have 5 or 6 use cases that we can go into that can talk through what the solution is capable of doing. And we can field any questions that comes in after that. Okay. All right. So let's log out here. So you are in Pipeline Toolbox. It's a cloud-based architecture, like I said. So pipeline engineering software, that's where we have hosted the solution. Once you are in, we are SOC 2 and Okta compliant. So you can essentially have your login process through SSO. So that is essentially logging you through the Hub platform, as you can see. Now, once you're in the Hub platform here, at the top is where your different solutions are. Like I said, we have developed a platform that can house multiple solutions. And for today, it's Pipeline Toolbox. And this is where the location is for Pipeline Toolbox Gas and Liquid. So as you see, these are the different modules that are made available within the Pipeline Toolbox Gas and Liquid. And depending on what the fluid that's flowing in the pipe, you can essentially select the differentiator, that's gas or liquid, and you can essentially do that. And that is something that we can do here. Now, the next thing here is, sorry, just my screen. Here, as you can see, on the left side, what you see is the hierarchy panel. So if you are a user that would like to essentially organize your analysis based on a project or based on what your unique needs are, you have the capability to do that. That's one more level of organizing for data validity, data validation, for essentially going back and verifying your analysis. That is something that the tool has done. So right now, it's essentially filtering the hierarchy panel for me to look at it from a project standpoint on the different projects that I'm doing. So as it's loading, let's look at a few additional capabilities that the tool has, right? So now, this blank space here, that's called as the dashboard. You can, at any given point, select multiple calculations or solutions here that would be enabled, and that would essentially load into this calculation module, and you can essentially select those calculations here. So as you load your calculations, it's essentially loading here one after the other. That is what the canvas does for you. Now, I said streamlining your workflow. So this on the right side is the dashboard. So you can organize your dashboard based on what unique needs is. At any given time, we support up to 10 different unique dashboards. In this case, as you can see, I have a dashboard that I've created just for my analysis here. There's a workflow that I created that I would like to do. So in that case, when I select that workflow, it basically loads the calculation or the analysis that I would need there. So you as an engineer, if you are in construction or the pipeline integrity or the maintenance piece, you have certain modules that you work with that are on a day-to-day basis. And what the tool can do is it can basically load your customized dashboard based on that. And that is what it is. So you can always switch back to your different dashboards. and based on which dashboard you are in, the solutions or the modules gets loaded there. Now, within any calculations that we select, so let's say, we are selecting bending stress or analysis or the bearing capacity. There are two things that are important in our workflow, how we do. All our calculations are standard calculations, which means we have a comprehensive help documentations. Click on the help icon, it would essentially load the help documentation that talks about what the calculation is about, what the workflow is, what are the quick synopsis on how to essentially run the calculation. Everything is made available for you at the click of the button. The second piece is the documentation. What kind of documentations you can essentially gather from the calculation. So there is what you call as a report functionality. You can essentially generate the report in a PDF or an Excel format, and we can essentially generate the report. Let me show you an example of a calculation where we are doing an analysis and we are essentially generating a report here. So I'm in hydraulics. I've selected panhandle A as an analysis here. And this is a case that I have here. So when I generate a report, it generates a PDF report here with the calculation, with all the input, with outputs, including the reference documentation from where the calculation is derived. And this is standard across all the calculations that we do. Now, we also spoke about collaboration, and the collaboration is a feature that's made available within the tool. So what you can do is, let's say this is a particular case that I have created, and it's created by, under created by, it has my name, and me as a team member, I would like to share it with my team members so that I can get their feedback. And Gen collaboration on essentially enables that feature. And when I save it, what it essentially does from this point onwards is this case is shared across your company, and you as a colleague of mine can see my case, critique my finding, do a cross-reference here. You wouldn't be able to overwrite my case because I own the case, but you can essentially collaborate and share the case and get the review done there. That is the additional collaboration feature that we have within the tool. Now, let's look at some unique cases or analysis that we can do with Pipeline Toolbox. And in this case, I've selected 5 or 6 unique examples, but the workflow, the process, everything remains the same. So these are just 6 that I randomly picked. Here, as you can see, I'm in the hierarchy panel. What you are seeing here is I have different projects that I have. And under the projects, depending on which module I'm working with, I can essentially have the filtrations, I have the documentations done to essentially reference the calculation, reference the modules that I'm using so that I can have a digital footprint, digital documentation of what I see there. For the first example, what I want to do is I want to look at gas hydraulics. As you can see, these are the different modules within hydraulics that we have, right? So we have a good split of calculations that are applicable across the wider audience. So if you're in transmission, you have calculations that can handle the transmission line analysis. If you are in distribution, there are tools that could essentially handle the distribution lines. In this case, let's say, I'm interested in Muller low pressure and Muller high pressure that are mostly worked upon in the distribution line. And I have the capability to essentially run the hydraulics analysis here. So here, the workflow is very simple. Depending on what your unknown parameters that you're doing the analysis, I can select the calculation that's required to do the analysis. In this case, I want to evaluate my flow rate for an analysis, and this is essentially something that I'm looking for. And I can simply select that module, and I have access to the calculation here. So here, this is essentially where you have multiple cases loaded here, and I'm selecting a demo case that I have built in here. So I'm tasked with an example here. So I have a line pipe data here, and I'm looking at a validation point. I want to validate, hey, this is the metal with the schedule, with the fluid that's flowing is gas. I have an inlet pressure of 2 psi. I have a gravity of 0.60, and I want to evaluate and see what my flow rate is corresponding to the length and to the validations and to the inputs that are being entered here to see between upstream and downstream pressure, am I getting the right flow rate as it's recommended from the catalog that's shared here? And what I can do here is I use the same input for my validation here. I select my pipe from the different pipe catalogs here. I have multiple pipe catalogs here. In case if I don't have a catalog or a pipe that's not specified, I can always select custom pipe and select the custom pipe as a solution. I entered my pipe configuration here. I have the length of the pipe, and what you see here is the different drop downs for unit of measure. In this case, we had from that example as the length is 60 feet, and that is essentially what I'm entering here. And in the operational parameter between upstream and downstream, I have entered what my upstream and downstream pressure is, what my catalog, from the catalog here, I'm selecting natural gas because it's mentioned that it was natural gas and the specific gravity is 0.60. If I don't have a particular fluid that I want, I can also randomly select user defined as an option and define what my specific gravity is. Once it's done, what I'm getting is I'm getting the flow rate, and in this case, the flow rate was in cubic feet gas per hour. And what the tool is essentially capable of doing is, I mean, you can essentially select what your output is that you want there. And in this case, I'm selecting cubic feet per hour, and I'm essentially getting the flow rate that's corresponding to the calculation. Those are the kind of validations that you can do within the hydraulics tool. And in this case, I mean, this is the standard Muller high pressure and Muller low pressure calculation that's coming in from the handbooks. And we have built in the solution to be as detailed as possible to simply reflect the standard calculation. And those are the kind of analysis that we can do here. And finally, you can essentially save your cases. And in this case, I've saved these cases here. Let's say if you have a new case, you click on the create new calculation and you essentially enter your data. And once it's done, you save it. And at that point, that case is saved and you will have the drop down with the multiple calculations here. And finally, maybe you want to generate a report. You click on run report and that would generate a report here. And this is what the reporting would look like. It has all the inputs, all the output. In this case, the output was flow rate in that unit of measure that I selected. And that's what it does. And we as users, we can customize how the report would look like, meaning you can essentially define, you can essentially have your company logo updated and you can customize it for your unique needs. So that's an example for Muller low pressure. Same thing goes for Muller high pressure. Same workflow. You select your pipe configuration. You have your operational parameters, the fluid catalogs. You can essentially define your flow rate, and you can essentially do the analysis there. And the workflow remains the same across all the hydraulics module, depending on what your fluid type is, whether it's gas or liquid. You select hydraulics as a module. You select the calculation. You select what your unknown is. You can essentially run your calculations based on that. And all our calculations are validated against the industrial standard. So any calculations, we essentially reference it against the recommended practices or the recommended documentations, and we validate it against the board. Now, one additional thing is, I mean, because we do a standardized workflow process, let's say if I have any questions here, what I can do is I can basically use my support center checkbox here, contact my support team if I have a question, and they can essentially link it to my Jira ticketing systems where tickets can be generated. Let's say, I mean, if I have a question on the calculation or the validity of the calculation, what I can do is I can use my integrated AI model, that's Piper. I can click on Piper. I can ask Piper a question on applicability of the model. When I ask Piper a question, and let's see what Piper returns. So I asked Piper a question on when I can run the Muller low pressure calculation. So it's basically generating the responses there. And that is something that from a tool standpoint, we can essentially do that. Here, let me just so the Piper is our large language model that we have utilized. So it's built based on the industry standard, and it's essentially closed compartmentalized. So it's not fetching the information from the outside sources. It's using the internal resources to essentially give you the answer in the context based on that. As it's generating, let's close this. Let's basically go into a different workflow that I have. So here we are moving away from hydraulics and to something else. So let me just give it a quick refresh just to make sure all the updates are synced. All right. So what I'm going to do next is I want to look at a plastic pipe module because it's a comprehensive module and it's applicable for a lot of audience here. As you can see, in plastic pipe, the polyethylene pipe, we have a whole bunch of calculation that covers the design and the load analysis for the plastic pipe. A lot of these calculations are coming in from the plastic pipe handbook. So that's from where the standard source of recommendation is. And the tool is essentially comprehensive to essentially evaluate the design for the plastic pipe and also to essentially handle the load analysis, whether it's the wheel load, the track load, those kind of analysis for the plastic pipe. And that's a tool that's here. So here, I mean, what I'm going to do first is I'm going to clear up my dashboard. Before I clear up, look at this, right? So I essentially asked Piper a question on a location class. I mean, that's not a much more of a relevant question here, but I essentially asked Piper a question on, hey, what's the difference between location class and 1 and location class 2 in ASME B31.8? And it's essentially giving me a breakdown of the responses. So those are the kind of like close collaborative interactions that you can have with the calculation and with Piper that can essentially contextualize your responses based on the work that you're doing and based on the industry source that you're working. All right, so here, what I'm doing next is I'm selecting polyethylene pipe. I want to do some designing for the plastic pipe, and let's see how we can do that, right? So here I have design pressure for polyethylene pipe. And here also, if you see my help documentation, when I click on the help documentation, it's taking me to a documentation that's centered around plastic pipe for that particular calculation, what the introduction is, what the equations is, what the workflow is, some examples based on that, and also some frequently asked questions that we centered around that. So we have created our documentation process around that. Now, in this case, I have selected polyethylene pipe. So one of the things is essentially basically running the catalogs for the PE pipe. So we have the hydrostatic design basis catalog already integrated. So I'm selecting data from the hydrostatic design HDB catalog. So this is essentially coming in from pipeline plastic pipe handbook, and based on the HDB design material designation and the design temperature, I'm getting my hydrostatic design basis that's coming in from the catalog there. So here in this case, I have a case that I've built for a calculation that uses the hydrostatic design basis to essentially pick up my hydrostatic design basis and also design temperature and the design factor based on the fluid that's flowing. So based on all these conditions, I mean, I have my pipe configuration selected, I have my design pressure defined here, I have my hydrostatic design basis and the design factor coming in from the catalogs based on the recommendation from the plastic pipe handbook. And it's essentially helping me calculate what your minimum wall thickness is for that particular design that's capable of handling the analysis here. Now, what it can also do is, I mean, basically you can essentially generate the report, you can essentially document your analysis process, all those things can be done there based on that. So a different example for us is to essentially do the design pressure evaluation for polyethylene pipe. Here too, the workflow remains the case, same. I mean, in the other case, I mean, we were calculating the wall thickness. In this case, we are essentially calculating the design pressure. Again, the catalog is fully integrated because we are compliant with the latest version of the Plastic Pipe Institute catalogs. So you have the hydrostatic design base coming in from the catalog selection here. You select what the PE pipe designation is, and we have a short note on what it means, and then you essentially select what your design temperature is. Once you have it, you are essentially selecting what your design factor reference is. In this case, I'm selecting potable water. You have the polyethylene pipe catalog that I selected here from the catalog selections. You essentially select your pipe configuration. You have your hydrostatic design basis and the design factor. And I'm getting a design pressure that's calculated in accordance with the Plastic Pipe Institute recommended practices. And those are the kind of things that you can essentially do. And in plastic pipe, you have all these different calculations here that essentially handles whether it's design, whether it's operations, or whether it's stress analysis calculations. In the next one, what we are going to do here for a different workflow analysis is I want to do a load analysis here. I want to do a live load analysis for a multi-wheel old buried PE pipe. Here in this case, I'm doing a concentrated point load analysis. Now, I'm in polyethylene pipe. I'm selecting multi-wheel or pipe with a concentrated point load analysis. Now, as a user, maybe there are certain clarifications that I need here. So here, what I'm going to do is I selected the calculation. In this case, if I need more reading, what I do is I select the help documentation to essentially get into the context of what that calculation is. Maybe there are scenarios where I want to know more about the calculation. So there is an onboarding video that talks about what that calculation is, how the calculation is performed. There's a workflow, there's a breakdown of the equations used, what our context for the reference documentation is, everything centered around that. Now, let's say, if I have enough knowledge, I basically go into the calculation here. So first and foremost, what I'm selecting is what's a different kind of calculation method that I want. In this case, I've selected present load because that's what I'm referencing here. Then I go into the point pipe soil data, and here I have all the information that's centered around the pipe and soil data, including unit weight of soil, what my soil height is, the trench width is. Once I have that, I have the option to select pipe from the different catalogs here. If I don't have it, I have the option to overwrite with what information I need. Once I have it, I have the modulus of soil reactions and the native mold soil reaction that's essentially coming in there. And in this case, this is essentially something that we are entering here. And that is something of a user entry here. Then you have your deflection lag and the bending factor that we enter. Now, the next piece is essentially the pipe description. You select what your pipe OD is. There is the catalog integration with the ASTM 1962 table that's essentially coming in from the Plastic Pipe Institute. Here, it's a reference table. You can essentially select between HDP and MDP pipe. You can select what your duration time for the installation is, and based on that, you essentially get what your apparent modulus velocity is. That's what you basically use for the calculation here. So in this case, I'm selecting MDP. I'm selecting 10 hour for my installation time, and I have a P apparent modulus velocity that I'm using for that. Same goes for the safe deflection limit for the pressurized pipe. Here too, what we're doing is we are essentially relying on the catalog data to essentially give you what your deflection percentage is based on the pipe diameter ratio. If I don't want to stick to that, but I want to just enter my user-defined selection, so I select user-defined as a selection here, and I have the user-defined entry here. So now the next piece is basically what my live load configuration is. I essentially have my live load. I essentially have my impact factor defined here. I have my configuration here. Once I have these things here, I have my results with the pass-through criteria that's coming out of the analysis process here. So those are the kind of things that I can essentially capture it from my analysis here. And in this case, it's a V load analysis for a concentrated load that I essentially have my analysis coming in. So the next calculation or the workflow that we're going after is the purging calculation, because that is something that's important here. And let's go through that. I'm here, I'm going into the facilities. As you can see, I'm in facilities here. And once I'm here, I select the purging calculation. This is a common occurrence or a common calculations that you deal with on a regular basis. I mean, you're essentially doing a purging analysis here. And here too, I mean, basically the documentation is standardized. So you have the standard calculation reference from where the calculation is coming in, from what the calculation is, what the equations that are governing the calculation is, everything that's centered around that. All those kind of analysis that's coming in from here are properly documented. Now, once you're here, you basically have your input parameters. In this case, I mean, we're what your factors are, what your unique scenarios are. Kesley's singing. I have to speak a little louder. Can you guys? I hope it's better, Kesley. Can you just give me a thumbs up?
Yeah, we can.
It's better?
Yeah, we can hear you now.
Okay, sorry. That's my bad. All right, so this is a purging calculation model here. So you have your input set centered around the purging. Again, the fluid properties of the fluid catalog here, you can select the fluid catalog, whether it's internal or external. In this case, it's internal catalog, and I have all the different catalog data here. So in this case, I'm selecting natural gas. And for the purging, you're essentially having the blow-off pressure. You have what your blow-off size is. In this case, I mean, these are the different blow-off sizes that are coming in from the documentation that's there. Let's say you have a unique scenario where your blow-off size is above the configuration or the defined size here. You have the option to essentially enter your configurable blow-off size. And based on that blow-off size, I mean, we are asking you to at that point enter your blow-off coefficient. And what you can do from a usage standpoint is you are seeing a exponential, a linear curve here, sorry, not an exponential, linear curve here based on what your blow-off coefficient is as a function of blow-off size, and you can essentially extrapolate and get your unique blow-off size. I mean, if it's outside of what our recommended catalog data is, and we essentially have those information made available in the documentations to essentially help you navigate that. And these are the results that are coming in. I mean, you're essentially looking at what your volume of gas lost is between the minimum time and the recommended time, and that is a standard procedure that you want to do the analysis with, and you need a standard calculation for that. And in this case, our purging analysis calculation is capable of doing that. So that is something that we do here. Next up, I have a calculation for the accidental gas relay. So let's look at some of the modules here. So this is a question where we're going to ask that question sometime down the road here. These are the different modules that are available within the Pipeline Toolbox gas and liquid. In the gas, HER and GPRA, accidental gas relays is the module here, and you have all these calculations that's centered around us. Cathodic protection has all the different cathodic protection practices and the models that are made available here. Now, when you go into compressor, the compressor sizing, compressor head calculations, the calculations and the models centered around compressors and the compressor analysis are available here. Now, that is how we have structured the calculations. And now, when you go into regulators and meters, the actual AGA, American Gas Association recommended practice, and the models are made available here. For the testing, different kind of testing calculations, including the blowdown, the semi-empirical model, the pack and the pipeline, the purging calculations, everything is under the testing. Hydraulics we previously covered. Pipe blast, I don't know, I mean, how important it is, but we have a pipe blast module that covers some of the common practices for the pipe blast analysis. And for my case here, I'm looking at the accidental gas release. I want to look at accidental gas release for one or two scenarios here. So I want to look at accidental gas release for a small hole in the pipe to evaluate the amount of fluid that's coming out of the pipe through a small hole. In this case, it's a gas rupture. And here, again, I mean, let's look at where the reference is coming in from. So I generate the report, and I can see the references coming in from Handbook of the Chemical Hazard Practices and USFEMA process. Once I have it here, I know where my reference is. I mean, if I go into that book, I should be able to find the calculation. So essentially run this analysis here. I have an example scenario that I built here. I'm selecting the fluid property first, and in this case, internal catalog is what I've selected. And based on my specific gravity and my operational parameters, I'm calculating what my critical flow ratio is and other parameters that are coming in out of it. Under operational parameters, I'm entering my operational temperature and the base pressure. The next is the conditional checks for the actual gas release calculation, what my line pipe pressure is at the leak location so that we can evaluate the pressure drop, what my discharge area is, and what my release time is. Based on that, I'm calculating what my gas discharge flow rate is and what my volume is based on the time for which the release is happening. And that is something that I calculated based on the recommended practices here. And there are multiple analysis that we can do here in the actual gas release. I mean, here I have selected small hole in a pipe. There is a condition check where, I mean, you can essentially evaluate what happens when a full rupture in the pipe happens. And that is also coming in from standard calculation procedure. Uh, and if you want to essentially evaluate a potential impact radius of a leak, you can essentially run that through the calculation. And that's also available here. Under facilities, we have multiple different facilities calculation, whether it's hot tap sizing or relief valve sizing. So these are all calculations made available under the facilities module here. So that is roughly a high level overview on what Pipeline Toolbox does. And I want to show you something here on how we check the regulatory code settings and the regulatory recommended practices here. So let's say I'm in pipeline facilities here. So there is a recommended practice to essentially gather what are the standards under which the calculation is performing. So in this case, I have what my regulatory code standard is. If I select P31.8, it's essentially defining my calculation practice based on P31.8. If I select CSA, it defines the CSA as the optionality for my design factor and the calculation analysis that I'm doing there. So that is how integration of the catalog works. For the calculations that are very dependent on the reference documentations, references, and the governing regulatory framework, we have the option to essentially integrate it and have it made available for the calculation pieces here. So that on a high level covers some of the use cases and the example scenarios that I wanted to cover today. And again, I mean, we focused mostly on the utility related calculations and the practices. There are, however, 250 plus calculations under Pipeline Toolbox gas and liquid that can cover unique scenarios that you're interested in. And that is all made available within the Pipeline Toolbox gas and liquid. I also want to spend a little bit of time on adjacent aspects here. So if you see our help documentations here, the reason why support and onboarding becomes a clear path in making sure the full advantage of the solution is taken is important, and we believe in that. So we have a knowledge center that documents all the calculations, all the practices, everything here. So our documentation, this is what our knowledge center looks like. So if you're getting started, if you want an offline onboarding, we have a getting started package here that looks into what the different steps are that would essentially help you do that. If you want the product learning videos, we have learning videos that centered around Pipeline Toolbox, whether it's gas or liquid, and it covers a whole bunch of calculations and the models there. I showed you unique help documentation for each pages. If you want to essentially comprehensively look at it, this is the location from where you can start looking at it. In addition to that, we have live support made available. So a good way for us to expand our offerings and get the best feedback is essentially having a live integrated tech support. So you can report your bugs, you can essentially have questions answered, you can essentially have feature requests made live. All these things are made available within a fully integrated platform, and that's what we call the hub as a platform that's integrated with all the different solutions. And whenever a release happens, I mean, you basically see the release updates coming in here. As you can see, this is how transparent our workflow process is. Anytime when a release happens, we have a release documentation that's released here. So every week, I mean, we have a release cycle, and this is the release note for that. So let's say, I mean, last week we had a release cycle here, and when you look at it, it gives you a high-level purview on all the release documentations that are coming in out of that. So that's on a high level all the things that we do, and I'm going to get back to our slides because we have a few more things to cover from the slide. Let me stop sharing and reshare. Just a second.
Thank you, Febin. So next we're going to get to all of your questions from the attendees, but first things first, we do have a couple poll questions to cover. These are multiple choice, so you're able to select more than one, and we'll leave each one up for about a minute. We'd love to hear your thoughts, kind of what Febin was just talking about, your responses here, all of your feedback that we get helps guide us in how we can better support you moving forward. At Technical Toolboxes, we already work with many utility companies, especially those involved in gas distribution and infrastructure. But we're seeing a growing need across municipalities and public works projects as well. So whether your focus is more traditional oil and gas, or you're handling engineering challenges in water, sewer, electric, telecom, waste, your feedback helps us understand where our software can bring the most value to you. So these poll questions help us kind of guide our product roadmap going forward for the next year. We'll give this one another few seconds, and then we'll move on to the next question. As soon as that wraps, we will go into our live Q&A. So the next poll question should be, what calculations or modules are most useful for you in your day-to-day job? Again, you can select more than one if multiple apply. I suggest you doing that. Our goal is to really just simplify the workflow with our software that is not only accurate, but field ready and aligned with the way you already work, integrating that into your daily workflow. So again, whether you are a private utility company, a public agency, or a contractor supporting them, we want to understand your needs and provide tools that take some of the load off of your plate. So we're always evolving our platform, always editing our product roadmap, as Febin well knows, and your input here helps shape what comes next. So it does look like we did have a few questions come in from the audience. As this poll question wraps up, I'm going to go ahead and start reading those to you, Febin. The first one we have from Alex is, when running the flow calculations, can you use multiple pipe sizes and combinations, or is it just a single size at a time?
Right now it's a single size, but our goal is to essentially have a network with multiple sizes to do that. Right now it's a single size that you do.
Okay, very nice. Easy answer for Alex. This one's coming from Bryant. Are you guys doing any PVC or ductile pipe analysis?
You read our mind. I mean, that's our roadmap. That's the next thing that we're working on. So yes, we will have something on that next quarter, because we heard our customers and we are working on that.
Great. Maybe this is someone that's already given us that feedback.
That's a good one.
That's good to hear. Next question. If there are calcs that are missing that needed to be added to your platform or your solution as they refer to it, what does that look like as far as procedure and timeline?
So the way we function is we are completely product focused. So what it means is we open up our feedback loop and we essentially have the enhancement, the feedback channel there. So whenever a client essentially comes in with that, the framework for us to essentially add new calculation is like ductile and PVC pipe. We heard from multiple clients that, hey, this is something that we need because you guys are doing plastic pipe, HDP and MDP pipe. I mean, we want PVC and ductile. We heard enough conviction from our customers that, I mean, this is a standardized calculation that they would need and that can be utilized across the board. And that essentially moves it up the priority list, and we do that. So sometimes, I mean, some of these decision making takes a little longer than expected. It's simply because, I mean, we want a confirmation bias. We are hearing the same thing from multiple users and we are doing the right prioritization, but that's how we develop modules and calculations across the board. And all the products that we have.
Very nice. And I think this is the last question, unless anyone who has remaining questions, please submit those now, and we can try to cover those real quick. The last one I see here is, and I think you covered this at the end, do you provide training to onboard the users?
We do, and that is a big focus for us because we want to make sure users take full advantage of what we are offering, and that process involves having a customer success engineering team working with you. It can be offline or online boarding, but we appreciate both, and that's something that's available here.
Awesome, thank you, Febin. Unless there are further questions, I haven't seen anything else come in, we will wrap up here. So thank you all for your attending and submitting your questions. If you have follow-up questions, our contact information is here. This is Febin's direct email address, as well as our website. Feel free to reach out, submit those questions. If you'd like to see a more tailored demo to you and what your team is doing on your day-to-day, as well as your projects, we would love to set something up with you and your team. You can also reach out via the website or Febin's email address that you see there. We would love to accommodate that. Like I said, you will receive an email with this recording in the next couple of days, as well as it'll be available on our YouTube channel to share with others and your teammates. I want to give special thanks to Febin for the presentation and for everyone in attendance. Again, if you have additional questions or interests, please contact us. We would love to talk to you outside of the webinar. Thank you all. Have a great day.
Thanks, everyone. You'll have a good day. Bye.